everyone, a very warm welcome to all of you. It's snowing outside, it's a beautiful day. If this is your first time tuning on to Electronics with Professor Mughal, you might consider navigating through the channel, and if you like it, please subscribe it and join our community of more than 4,000 followers and subscribers on Facebook, Instagram, and YouTube. This is going to be a very interesting video, and I have spent quite a bit of time. What you have seen probably in your electronics class or lab is working with these digital logic gates, AND gates, OR gates, exclusive OR gates, and different kind of other logic gates. You put the logic and you verify the property of a logic gate. Okay, so for example, if you have an AND gate, both inputs are high, output is going to be high. So you know that part of how digital electronics work, but you probably might not know what is inside this chip that you see in my hand. Okay, this is an inverter. So inverter, logic 0 is applied, it's going to invert the logic, and at the output you'll see 1. What goes inside is basically transistor and some resistive components. How those transistors are wired up together and how other resistive components they make up these logic gates, that is what we are going to learn in today's lecture. So I want you to focus on this circuit that you can see over here. Before I get started on this circuit right here, I want you to focus on the transistor. Now those of you who don't have the knowledge of transistor, that's perfectly fine. Please don't leave the channel, don't leave the video, just stay tuned. You don't necessarily need to know how transistors are constructed or they necessarily function. All you need to know in order to understand how we use transistors to make logic gates is we are going to use transistors as a switch. Okay, consider it as a switch that controls the flow of the current. Okay, and the symbolic representation of a transistor is basically, it looks like this. This is the flat end of the transistor. Let me just show you real quick. A transistor may look something like this. Okay, so if you notice here, this is the flat side and this is the other side is the round. Okay, so if you look at it like this, the leftmost pin is going to be emitter, the middle one is going to be base, and the rightmost pin is going to be collector. Okay, the symbolic representation is right here. You have the collector terminal, you have the base terminal here, and then you have the emitter. Okay, so it's basically a current control switch which allows the current to flow from collector to emitter. Okay, now let's learn a little bit more how it's functioning as a current control switch. Most times, to explain how transistors are working as a switch, we use the water analogy that you see over here. Okay, consider a faucet. This is the valve right here, and then you have the collector current right here, which is basically the main power supply where the water is coming. When you open the valve a little, the current will start flowing and it will come out of the faucet, and that's what we refer to as emitter current. Now emitter current depends upon the collector current and the valve. So if you have valve open all the way to the very end, then the water flow will gonna be more. So in this case, when transistors are used as a switch, a tiny amount of current going to the base of the transistor will allow the current to flow from collector to the emitter, and that's what's happening over here. Okay, another way to understand is, think of it, this is the collector terminal right here, this is the emitter terminal right here. Okay, and these are the metal contact that you see in black. Okay, notice here, base, which is the base terminal of the transistor, is not actually making a contact with collector and emitter. So for the current to flow from collector all the way to emitter, this base needs to make a contact with the collector and emitter terminal. So when the base current is applied, what happens, this metal is going to make contact with these as it is represented by this dotted line. And once this makes a contact right here, the current is going to flow in this direction, and then at the emitter you get the current. Okay, so that's the basic functioning of a transistor as a switch. Now let's move on to circuit 1. What you see on the screen is basically you have a 5-volt DC supply here. Okay, so the current is going to flow. Remember, the conventional current always flow from a direction of a positive terminal to the negative terminal. So it's going to move in a clockwise direction. Here we have a resistor right here, and then we have a switch over here. This switch is normally open. So therefore, there's no way for the current to travel into the base of the transistor because the switch is open. Another route that current can take is going this way, but then it goes through this resistive load and then the LED, and then once it comes over here, because there's nothing at the base, the collector terminal and emitter terminal are not making contacts, just like I mentioned over here. Therefore, there's not a way for a current to flow all the way to the emitter and then go to the negative terminal, go to the ground. In order for the circuit to work, it has to have a functioning such that the current is able to move from positive and all the way go to the ground. And because that's not happening here, the LED is not going to light up. However, when I press this switch, then there is a current that's going into the base of the transistor. That means the current was over here at the collector terminal. Now it's going to go past base and then emitter and all the way to the ground. Therefore, completing the circuit, and this red LED light is going to come on. I have this same circuit built on a breadboard right here on this part of the breadboard. What you see over here, I have this resistive load connected to the 5-volt power supply, which is then hooked up to LED, and this LED is basically connected to the control, not the control, but the collector terminal of the transistor. The base is connected to the switch, and then emitter is connected to the ground. And we also have 5-volt coming in into the push button, which is going to be used as a switch. I'm going to supply 5-volt. This is my portable power supply from EIM technology. I'm going to do a separate review on this because I thought this is pretty cool. Now notice here, as you were expecting, as soon as I plugged in, we were looking at circuit 1, remember. As soon as I plugged in, nothing happens because the switch is normally open and there's nothing going to the base of the transistor. But when I press this button, there's a tiny amount of current that goes into the base of the transistor, which basically connects or give a route for electrons to flow from collector to emitter terminal, completing the circuit, and hence LED goes on. That's what you see. And as I remove my finger, it becomes normally open and there's nothing going into the base of the transistor, and therefore the circuit is not complete. So this was pretty simple. Now let's move on to circuit 2. Let's move on to circuit number 2. What's happening over here? I've made little changes to this circuit. The only change here from the previous circuit is that this LED is now not in series with the resistor and the collector terminal of the transistor, but it's actually in parallel. Okay, and the voltage across that is we consider it as the output. Now what's going to happen? So the 5-volt here, the current is going to go past this resistor over here. Notices that the switch is normally open, so there will be no current flowing into the base of the transistor. The current will try to take this route, and once it gets over here, the current gets over here, it has two options, whether to go to the collector terminal of the transistor or go through the load, which is the red LED light. But because there's 0 amps over here at the base, there's no connection between collector and emitter, current will take this route and then go past the LED and then return to the negative terminal of the battery, therefore completing the circuit. So without this switch being, regardless this switch being open or closed, red LED light is gonna be on. Okay, now this is again the same circuit that I have right here on the left, which is mentioned as INV. This is basically a short form for inverter. What you see on the sheet is basically an inverter circuit. So right now normally open, so that means 0, output is going to be 1, and therefore the LED is light up. When input is 1, that means if I press the push button, the LED is gonna go off because the invert of 1 is 0. And therefore what's happening here, when I press 1, now what is gonna happen? When I press 1, that means this switch is gonna be closed. This switch is going to be closed. Current is going to go here to the base of the transistor. The internal resistance of the transistor, is a lot more less than the resistance of the LED. Okay, depending upon what color it is going to be in few hundred ohms or slightly less than that. And because remember, current always likes to take the path of least resistance, so current will basically go to the base terminal, go through the emitter, and then go over here, and it will avoid taking this route over here going past the LED, because current always take the route of the least resistance, and therefore no current flowing into the LED will be off. And that's what's happening over here. When I press the button, I basically complete this circuit, this part of the circuit, and it will not take this route because it's got this resistor and this resistive load. So if you combine those two, that resistance is going to be a lot more than the internal resistance, which is going to be in like few ohms. It's really 7 to 23 ohms. Okay. All right. This was your inverter gate. Let's now move on to the next circuit. Okay, what's happening over here? You have a 5-volt source going into a resistor and then connected in series with an LED. All right. In series, you also have 2 transistors right on top of each other. The base of the transistor is connected to a switch or a push button. Now what's going to happen? The current is going to flow in this direction. Okay, because there's a disconnect between these two. If A is 0, normally open, and B is normally open, okay, initially, therefore there's no connection between the collector and the emitter terminal, right? Collector and the emitter terminal. So current is not going to flow this way and all the way to the ground, therefore LED is going to be off, right? Even if I press A, that means A is pressed, then it does make a connection between collector and emitter. But once the current comes over here, because B is normally open, it's still 0. There's no way for the current to go from collector to the emitter terminal and to the ground, therefore not completing the circuit, and resistive load, which is the LED here, is going to be off. However, if I press both buttons, A and B, which means connecting this part of the circuit also, now my current can travel all the way through the resistor, through the LED, and through the 2 transistors, all the way to the ground, completing the circuit, and your red LED light is going to turn on. I keep saying red LED, but I have green LEDs here for the most part. Okay, let's now look at over here. This is my same circuit that I have drawn over here. Okay, I got my switch A, switch B. If I press, I need to connect my power supply here. Again, I am providing 5 volts here. If A is 0, A is 1, B is 0, off. That's what we were expecting. If B is 1 and A is 0, still 1. But if I press both of them at the same time, that's when the logic goes high. And that's because there is a clear path for the current to travel all the way through all these components and then go to the ground, therefore completing the circuit. So that's how you will make these transistors, wire them up with some resistive components, and make up logic gates. In this case, it was an AND gate. And this is the truth table for the AND gate. Anytime 2 inputs are high, the output is going to be high. Okay, so it's fairly simple using transistor as a huge, and then how we just design them such, or wire them such that they make logic gates. Let's move on to the next circuit, circuit number 4. Circuit number 4 is an OR gate. It's an OR gate. It's very similar to the previous circuit. The only difference is that here the 2 transistors are parallel to each other. They're not on top of each other or in series as it was the case in the AND gate. Now what happens? 5 volt is applied, the current goes past the resistor, goes past the LED, and then when it gets over here, it basically have 2 options. Either it can go here, it can go here. Now both the transistor of same kind. Now if you notice here, I have these already labeled. This is collector terminal, this is base, this is E. If you're wondering what is NPN, is basically NPN means there are 2 types of transistors, NPN and PNP. You don't necessarily know what they are, but NPN means is the majority carriers are going to be electrons. It's the electrons that can take part in the conduction. Please know that electrons and holes can both take part in the conduction. In this case, because it's an NPN type of transistors, so electrons are taking part in the conduction. Okay, and because they are same type, I'm using 2N3904, and this is also 2N3904. They both are same kinds and they have same internal resistance. Now the base is connected to switches or push buttons, which is, and I have labeled them as A and B. If A is, right now initially both of them are normally open, okay, normally open, so therefore it means there is a disconnect, right? There is a disconnect. Here is a disconnect over here between collector and the emitter terminal. So no current is going to flow, so therefore 0, 0 is going to give you 0. When I have A0, B1, so this is still normally open, I'm going to close or press the switch here, press the push button here, which basically gonna make a connection between collector and emitter. Current will take this route, go past the collector emitter, and then connect to the, go to the ground all the way, completing the circuit, and your light is going to turn on. If I do the reverse, A is 1, B is 0, current will take this route, go all the way to the collector, make a connection between the collector and emitter, all the way connects and to the ground, completing the circuit, and LED light will turn on. And if I have both of them turn on as a switch, as a transistors, then basically I have current will have two routes and it can take either one of them and then completing the circuit, and therefore hence LED will turn on. So let's see what I have over here. This circuit on the right, what you see, is actually a same circuit that I have on the sheet. Okay, I'm going to connect my portable power supply here. Now notice here right now it's 0, 0, so LED is on, and that's what we were expecting. If I press one push button, LED goes on. If I press B, then LED goes on. So we are basically following the truth table over here. And now if I have A and B both set to 1, so if I press both of them, I still get the LED high, output 1, and that's what we were expecting. So it's really about, you know, using transistor as a switch and then how we wire them up. So it's fairly simple. So I thought you should know what goes inside this chip is basically a bunch of transistors and resistive loads, resistors. Okay, very popular. It's a very simple. It's also referred to as a universal gate. Nand gate is also referred to as the universal gate because you can basically create any kind of logic gate, be it AND gate, OR gate, or inverter using Nand gate. It's a fairly simple circuit, very similar to that of the AND gate. The only difference is this LED that you see over here is not in series with the two transistors, but it's actually in parallel with the two transistors. Okay, so again, the route here for the current to flow is go past this resistive load, and because these A and B are going to be normally open, there is no connection between collector and emitter. It just simply goes through the LED and goes to the ground, and then therefore completing the circuit. So 0, 0 should basically give you 1. Now notice here these two combinations, when any of the two inputs is 0, when any of the two inputs are 0, you got A and B which are connected to the base of these two transistors. Any of this is 0 means there is going to be a disconnect. And if there's a disconnect, this current that's coming from here is not going to go all the way to the ground, right? Therefore not completing the circuit. Red LED is going to stay 1 because current will take this path and go to the ground. So for these three combinations, you will have both the LED basically high when both transistors are off or one of them is off. Now let's look at the last case. In this case, you have both inputs set to high. Both inputs A and B, they are closed now. They are closed. They are making a contact between the collector and the emitter terminal. Therefore current will go take this route all the way to the bottom, because the two internal resistance of these two transistors is going to be somewhere between 50 ohm, whereas the internal resistance of this LED could be somewhere a lot more bigger than this numbers. Current taking the route of the least resistance, going past these two transistors all the way to the ground, and red LED, there's no current flowing in there, and therefore LED is not going to light up. So it's going to give you 0. So I have the truth table for the NAND gate over here. We already know that 0, 0 is going to give us 1. Any of the inputs going into the base of the transistor is 0. The output is going to 1. And when both inputs are high, it is going to give us 0. So on the left, this part of the breadboard is my NAND circuit. And as you can see, I have my resistor, which is right here, connected to the LED, and then the negative terminal is connected to the ground. From here, I have this connected to the collector terminal of the transistor, this right here. The base of the two transistors is connected to the switches, and this emitter terminal is connected to the collector terminal of this transistor, and the emitter is connected to the ground over here. And hence it's basically this circuit right here, what you see on the screen. Now let's try a couple of logics, actually all 4 cases here. I'm gonna plug in my power supply here, and as we were expecting, when the logic is 0, 0, we should get 1, and that's what we are getting. A is 1, B is 0, which would still give us 1. A is 0, B is 1, which still gives us 1. But when both the inputs are high, meaning when I press 2 at the same time, both the inputs are high and output is going to be 0. And we know that because it's happening because the current is going to flow through these two transistors all the way to the ground and not going into the LED. So 0 amps here, and therefore the LED is going to be off. I wanted to do this for a very long time. I know some of you were waiting for this lecture. This lecture is actually dedicated to Jogesh, Ryan, Haris, and also Jonathan. They all sent me this request, and I wanted to do this for a very long time. It's just I didn't have the time. I hope you enjoyed this lecture. I know I went through fast a little bit because I wanted to keep it short, a few minutes, but please go back and watch it at your leisure time at a slow pace. And then if you like the video, if you find it helpful, please subscribe, share, give it a thumbs up, leave a comment, and I shall see you next time. Thank you. Bye.